Hello and welcome. In this video, we're going to learn Azure Compute Services. Let's get started and dive straight into the presentation.
All right, welcome back. Let's quickly look at the objectives. What we are going to learn, we're going to describe virtual machines and virtual machine skill sets. We're going to learn about Azure Virtual Desktop as to what it is and when to use it, and then Azure Containers and Kubernetes, and then we're also going to look at Azure Functions, App Service. All right, so that's what the agenda is. Those are the host of compute services that we're going to learn in this video. Right, so what does compute mean? Compute provides you the playground that you need to run your application. Okay, so compute provides the playground. So what I mean by playground, it gives you CPU and RAM. Okay, the two fundamental aspects that you need to run your application. Okay, now let's quickly look at the broader architecture of where does compute fit into this compute storage and networking architecture. All right, so let's assume this is a compute instance, whether it's a virtual machine or it can be a web app or it can be a container. Okay, it's a compute instance that provides you CPU and RAM. On top of it runs your application. Okay, and then this compute instance talks to the storage. Okay, where you store your data, and this storage can be in the form of a storage account or a disk or a database. But yeah, this is how the compute and storage talk to each other, and this is where your application runs. Right, all right, perfect. So let's move ahead. Now let's try to look at the compute instances or the compute services that are available in Azure. Now let's first talk about Azure Virtual Machine. So VMs fall under this IaaS category. As we discussed in our previous videos, there is three category of cloud services: IaaS, PaaS, and SaaS, and VMs fall under IaaS category. Right, with Azure VMs you can create and run VMs in the cloud. Okay, so virtual machines, as we know, they are similar to physical machines, but then virtual machines run on hypervisor. So let's, if you want to create your virtual machine, you want to use Azure virtual machines to do that. Now let's see the broader architecture, a bird's eye view of how does virtual machine fit into the entire hypervisor or physical machine architecture. Okay, so this is a server or a physical machine. On top of it is what we install virtualization software, which is also called a hypervisor. Okay, in this case it would be a Hyper-V from Azure. Okay, on top of it, as you can see, it's a Hyper-V on Azure. On top of it is your VMs get created. Okay, it could be a Windows VM, okay, or a Linux VM. So Azure creates virtual machines on top of hypervisor. So what hypervisor or Hyper-V allows us to do is to create multiple virtual machines on a single physical host or single physical machine. A hypervisor lets us create multiple virtual machine. Okay, now what are the benefits of virtual machines? So virtual machines allows us to take total control of operating system. Okay, so the entire operating system is something that we have control on. Whether you want to modify any setting, you want to make any changes to the registry of an operating system, you can do it using Azure virtual machine. And this allows us the ability to run custom software. Okay, let's assume there is a software that wants me to modify certain setting on the registry. Okay, in that situation I would want to use virtual machine to host that software. Okay, now when to use VMs? Okay, when running applications in the cloud, obviously. Okay, when you want to run your application in the cloud, and when extending your data center to the cloud. Let's assume that you have your data center, on premises data center, and you want to increase workloads that are running on your data center, but you don't want to buy a new physical server. Instead, what you can do is you can create VMs in the cloud, and that's how you can extend your data center to the cloud or Azure. During disaster recovery, okay, you can also host your primary virtual machine on your data center, and then your backup or disaster recovery on Azure. Okay, so let's say if your primary data center virtual machine goes down for some reason, then you have a disaster recovery version of your VM running on Azure. Right, so let's quickly head to the lab for the Azure virtual machine and try this out. Okay, now before we do that, what we're going to do in the lab is we're going to create a Linux virtual machine, and on top of it we're going to install an Nginx web server. Okay, so Nginx is a web server that allows you to run application, web application. Okay, that's what we're going to do. So so how it's gonna happen is the sequence of steps. We're going to create a VM first. Okay, once the VM is created, we're going to use custom script extension to install Nginx. So custom script extension is an extension that allows you to run scripts once a VM is created. Okay, and here is the script for virtual machine VM creation script. We're going to use Azure CLI to and use this script to create a VM, and then we're gonna use this script to set the extension. All right, so see you on the Azure portal. All right, perfect. So here is the script that I'm copying, uh, and I'm gonna head to the Azure portal. So I'm here on Azure portal, and then I'm gonna use the Azure CLI. This icon gives me the cloud shell. Okay, so I'm gonna use the Azure CLI. You might be wondering why we are not doing using portal. So there we have got multiple ways to create a virtual machine. We can go from the Azure portal here and create a virtual machine. This is self-explanatory and it would be easy. So hence I thought let's do it via cloud shell. Okay, so let's try it out. Let's load for the cloud shell to come up. There you go. So just gonna paste this script here. So what I'm saying is the script is azvm create resource group name. I'm giving the resource group name here. I'm saying Azure virtual machine create resource group name, and then here is the name of my VM. My VM is going to be the name of my VM. Then public IPSQ standard. Image is Ubuntu. I want a new Ubuntu virtual machine to be created, and then I'm giving my username and password. Hit enter, and once I hit enter, the VM, there you go, it's starting to create the virtual machine. Let me go here. There are no VMs as of now here. As you can see, there are no VMs. If I refresh, still it's not there. It's creating. Let me, there you go, it has created. So the VM is created now. It's still in the process of creating it. And there you go, it's still running. So we'll come back once it's finished. All right, perfect. So the VM is created, not ready, and running. From creating to running, it has moved from creating stage to running. So now it's running. Now we're gonna use, as you can see, so here is the ID, the VM virtual machine ID, subscription name, subscription ID, resource group, and then virtual machine name, and then we've got the resource group. Right, perfect. Now we're gonna install the extension. I'm gonna use this command to set the extension. And this extension, let's quickly look at the uh, command that's trying to accomplish. So azvm extension set is going to set an extension on this VM that's part of this resource group, new RG. VM name is my VM, and the name of these extension is custom script. Publisher is Microsoft, and then it's going to download this bash script from GitHub. Okay, and then it's going to try to execute. So let me run this script here. Hit enter. Right, it's running. Let's wait for it to finish. Now The way to check it on the portal is you want to go to extensions plus application here. This is where you see your extension. Oh, there you go. It has come up. So custom script extension that we just created. It's still in the transitioning state. Okay, let's wait. Provisioning succeeded. There you go. So it has successfully installed the extension on this virtual machine. Okay, so that's about it. All right, that's about it. So we've created the virtual machine. Now we're gonna come up in the next video where we'll learn about networking, and then we'll head to that virtual machine and try to connect to it and check the website. So as of now, the VM is created. All right, so let's proceed ahead. Now, let's learn about Azure Virtual Machine skill sets. So, when do we want to use virtual machine skill sets? What's the purpose of it? So, we want to use it when we want to create and manage a group of identical virtual machines. Okay, let's assume that there is a requirement for us to create a 15 VMs of same size. Okay, then VM skill set would be the right capability over there, and it also allows us to load balance VM efficiently. Okay, so yeah, that's so out of these 15 VMs, the load would be distributed across them, right? So now, challenges without skill sets. What happens if, let's assume, there is a no capability called skill set. Okay, so there is configuration complexity. Okay, manual setup and configuration for multiple VMs required. So if you have to create 15 VMs of the same size, then you have to manually set it up and configure them. Okay, which would be very complex. And then monitoring hassles. So ongoing monitoring for utilization and adjustment needed. So you'll have to ensure, or you'll have to monitor all those 15 VMs, but without skill set. So that would be also be a pain point. And then those are the challenges that one can come across potentially if there would be no skill sets. Okay, now let's look at the benefits of virtual machine skill sets very quickly. Automation. So Azure automates configuration, ensuring identical setup. So Azure would automate this creation of 15 virtual machines. Okay, and it also ensures that they are identical as the need for us is. Okay, and then centralized management. Centrally manage, configure, and update a large number of VMs effortlessly. And then dynamic scaling. VM instances automatically adjust based on demand. So what the benefit of virtual machine is that it automatically adjusts based on the demand. Okay, if there is a high demand, and then it would create extra VMs. So initially it has to start with two or three. We need to, based on the requirement. Let's say I want two VMs running at the start. As the load increases, I want more VMs to be created. So that's how it dynamically scales. Okay, and then schedule scaling. Let's say if I want my virtual machine skill set to scale at some time of the day, then I can schedule that. Scale based on a defined schedule for planned resource adjustment. Okay, and then load balancing. Automatically deployment of load balancer for efficient resource utilization. So yeah, those are the benefits of virtual machine skill sets. Okay, and then let's see, when do we want to use it? What's the use case? Okay, when should I use virtual machine skill set? So where there is a need for scalable services, when ideal for large scale services in compute, big data, and container workloads. Okay, so when there is a requirement where you want your compute instances to scale automatically based on the demand, then you want to use the virtual machine skill set. So conclusion, efficiency and automation, those are the two key takeaways for virtual machine skill set. Virtual machine skill set sets streamline VM management, ensuring scalability and resource optimization in Azure. Okay, All right, now let's look at the other capability called Azure Virtual Desktop. Okay, so what is Azure Virtual Desktop? Azure Virtual Desktop is a desktop and application virtualization service that runs on the cloud. Okay, so let's quickly look at this diagram, which will make things very clear. So here is a person sitting in his office, and here is the Azure Virtual Desktop hosted on the cloud. Okay, now why do we want to do it? Why do we want to do in this way? Why not give this user the machine to access it? So on this Azure Virtual Desktop, so companies, what they usually do is they host their business critical application or a sensitive application, and then which which means that this person or this user can access those application from anywhere. Okay, and then when once that is done, he can shut down his virtual desktop. Okay, so what's the benefit of it? This is secure. Okay, so since these applications are not installed locally on his laptop, there is no risk of the data being leaked, or let's say if this laptop is stolen, then it's a potential data loss for the company, and it's a security breach. So if those applications are or those files or data is residing on a cloud, and this person can access them using Azure Virtual Desktop, then it's a great solution because it's secure. It's cost benefit as well, as long as he uses it, this VM would be up and running. Once he stops using it, Azure would shut it down. And this is scalable as well. Okay, if there is, let's say, assume the VM size is not being sufficient, then this can scale as well. All right, so that's about Azure Virtual Desktop. And then let's look at containers. What are containers? Okay, the another compute service offered by Azure. So containers are virtualization environment for running multiple containers on a single host. That single host can be a physical host or a virtual host. So it's containers provide that virtualization environment for running containers on a single host. Just like virtual machines allows us to run multiple virtual machine on a single physical server, containers take this step further, and they allow us to run containers on a single host, be it physical or virtual. Now we'll try to understand why do we need containers. We already have virtual machines. Why do we need containers? We'll look at it. Okay, now let's look at the key characteristics of containers first of all. So containers are lightweight and dynamically scalable. So they are lightweight because they don't have OS running in them. Instead, they use OS of the virtual machine that they run on. Okay, so they just have binaries and libraries and application code running in them. So they are lightweight, therefore, and dynamically scaled. They can be created, scaled, and support stopped dynamically. So it's very easy for them to be created. And then there is no direct OS management for each container, as OS is not running on the container itself. There is no need for us to manage the OS. All right, let's compare now the architecture of or the building blocks of VMs versus containers. Okay, let's look at the virtual machine first. So as we saw in our previous slides, this is a physical server. Okay, on top of it we install a hypervisor, which can be Hyper-V for virtualization, and this hypervisor allows us to create multiple virtual machine on same physical host. Okay, so I'm running two VMs on the same physical server. Okay, now on top of this VM, if let's say if I want to run my application, then I need to install the needed binaries or libraries, and then I would be able to run my application. Okay, so now what if I want to run multiple application on the same VM? Okay, let's assume in the same Windows VM here, as you can see on the screen, I want to run two application. One is .NET and other maybe Python. Okay, I want to run it. Then that's the limitation, because that's not possible in the case of virtual machine. Okay, that's when the containers come into the picture. Okay, here is a physical server, and on top of it physical server, we install the hypervisor, which can be Hyper-V, and then on this hypervisor a VM is created. Okay, runs an operating system. On this VM is a container engine, which can be Docker is a container engine. On top of Docker, we install the binaries and libraries. Okay, and then we run the application. Okay, so here as you can see on the same VM, I'm running two applications. Okay, that's the power of containers. Containers allows us to run multiple application on the same host, resulting in efficiency, okay, and scalability and lightweight containers. Okay, so those are containers, and containers also allows us to run application using microservice architecture. All right, cool. Now let's try to compare containers and virtual machines very quickly. So operating system, okay, containers share the host system's kernel. Okay, so as we saw in our previous slide, on a single VM operating system, on the one VM, as we can see here, and this VM is running the OS, whereas both these containers are using this this operating system. Right, that's what it means. Shares the host system's kernel, and then whereas virtual machine has its own kernel. Portability, more portable. Let's say if I want to move a container from one cloud to another, let's say I want to move a container running on Azure to GCP, then I can easily move that. That's more portable. It's whereas virtual machine is less portable. Speed, faster to start up and shut down, slower to start up and shut down. Resource usage, use fewer resources, use more resources. Use cases, good for portable and scalable application, good for isolated application. Okay, so uh, container is good for portable and scalable application or applications that need microservice architecture, whereas virtual machines are good for isolated application where there is a requirement that that application exclusively need the OS running of a virtual machine. Right. Now let's try to understand what is Azure Container Instance. So the Azure Container Instance. So within the container umbrella, Microsoft offers three capabilities: Azure Container Instances, Azure Container Apps, and Azure Kubernetes Service. Okay, let's try to understand what is Azure Container Instance. So Azure Container Instance is the fastest and simplest way to run a container in Azure. Okay, so uh, and then you don't have to manage any virtual machine on or adopt any additional services. Okay, you don't need to create a VM for this. You can just go to portal and create a container instance. So it's a pass offering, platform as a service. So when do you need to use this? This is great for any scenarios that that can operate in isolated containers. Okay, so you need a container specifically in as isolation. That's when this container is instance is useful. So such as a simple application, a very basic application that I just want to run, then I can use container instance. That does yeah, that I can use Azure Container Instance. And then task automation, let's say I want to use, there is a certain code that I want to run, and I need to just run it in a container. Then yeah, I can just use Azure containers. And then build jobs for CI/CD pipelines, for Azure DevOps for instance. Okay, when you create a build pipeline, it needs a compute instance to run that code. Then you can use Azure Container Instance in that particular scenario as well. All right, now let's take a look at Azure Container Apps. Okay, it's same as Azure Container Instance, but however it has got additional benefits. Okay, containers have got extra benefits, such as container apps have got extra benefits such as ability to incorporate load balancing and scaling. The other functions allows you to be more realistic in your design. All right, so when to use Azure Container Apps? Use ACA, or if you want simple serverless and event driven way to run containers on Azure. Okay, you want a serverless a kind of a or event driven kind of an application, then you want to use Azure Container Apps. And you don't need to worry about managing clusters or configuring load balancers, okay, or service discovery or certificates. So all these things you don't need to worry about. Azure Container Apps take cares for you. All right, so that's Azure Container Apps. Now let's look at the Azure Kubernetes Service. Okay, the very popular Kubernetes service that's used by a lot of enterprises these days. So Kubernetes is a container orchestration service. Now let's assume there are 1,000 containers that I'm running. Okay, then in that case it would be very difficult to manage them. Okay, making sure that there is a network connectivity in place and each container is able to talk to the other one. In that case, Kubernetes comes into the picture. It's a container orchestration service. An orchestration service, man, what does our orchestration service do? It manages the life cycle of a container. Okay, right from startup to shutdown to when it fails, it reboots, to all that entire life cycle of a container is managed by Kubernetes. Okay, so when you're deploying fleet of containers, as I said, when you're deploying thousands of containers, AKS can make fleet management simpler and more efficient. It allows you to manage those huge number of containers very seamlessly. So when to use AKS? Use AKS if you want to build full-fledged Kubernetes platform that gives you more control and flexibility over your containerized application. Okay, so if you want more control of your nodes of the infrastructure, then you want to use AKS. And then AKS is ideal for complex application that require stateful components, custom networking, or advanced security features. All right, that's when AKS more makes more sense. Now let's look at Azure App Service. So far we have looked at two potential compute services, right? We have looked at VMs, right? We've looked at containers, and within containers we looked at ACI, that's Azure Container Instance, Azure Container Apps, and AKS. Now let's try to understand what is Azure App Service. App Service is also one of the hosting options, web application hosting options on Azure. Let's see when it makes more sense. If the goal is control and flexibility, then VMs and containers are the good choice. If you want more control of your infrastructure, more control of your operating system, then VMs and containers makes more sense. However, if you want to focus just on building code and maintaining apps, while you want to outsource your management of infra to Azure, then Azure App Service makes more sense. So Azure manages the infrastructure or the entire environment for you. You just focus on building the code, right, or building your application. Supports various app types. Okay, App Service supports various app types: web apps, API apps, web jobs, or mobile apps. Okay, let's look at them in more details. So what are the key features of Azure App Service? It's an HTTP based service for hosting web application, REST APIs, mobile backends. Okay, so it's an HTTP based service. If you want to, let's say, host a web application, www.xyz.com, or a REST API or a mobile backend, you want to use Azure App Service. Language support. So it supports .NET Core, Java, Ruby, Node.js, Python, and PHP. All right, and then it supports both Windows and Linux environment, and it has got integrated deployment and management from GitHub, Azure DevOps, or any Git repository. So let's assume you have built and deployed your code on Azure App Service. Now over time, when you want to modify your code, or when you want to make any changes to the code, you can use these CI/CD features that can be integrated with Azure App Service. All right, now types of app service, as we've already looked, let's look at them in more detail. Web apps, full support for ASP.NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. API apps, so API apps is also one of the app service that builds REST based web APIs with Swagger support. Then web jobs run programs or scripts in the same context as web or API apps for backend tasks. Okay, So it's web jobs is again same as, let's say you want to run a program or a script, for a web or API app, you can use web jobs, which is also a part of app service. Mobile apps build backend for iOS and Android apps with data storage, authentication, push notifications, and custom logic. So what this allows you to do is, you if you wanna, let's say you've developed the iOS or Android app, and you want to, obviously you need data storage, or you need an authentication mechanism for the users that use your app. So all those sort of technologies you can get on Azure, and you want to use mobile app for that. Okay, so that's what it means, right? So let's move ahead now. Infrastructure handling by app service, let's look at that now. Deployment and management are integrated, as I said. So you can go ahead and integrate your app service with deployment and management technologies such as Azure DevOps. From there you can create your CI/CD pipelines, and that CI/CD pipeline can talk to your app service and deploy the code, right? So endpoints can be secured, obviously. So Azure is a very secure environment, a very secure cloud platform, and you can secure your endpoints in app service. Then quick scaling to handle high traffic loads. So let's say your web app has suddenly got huge number of users accessing it, then app service has got that capability where it can quickly scale, okay, to meet that demand. And building load balancing and traffic manager for high availability, so it can handle huge amount of traffic with load balancing, right? Cool. So let's look at mobile app features. Mobile app feature quick backend, as I said, quick backend setup for iOS and Android apps. You have developed an Android app or an iOS app and you want to set up a backend for it. By backend I mean databases, authentication, all those sort of technologies you can do using mobile apps features. Cloud-based SQL database for storing mobile app data. Authentication against social provider like MSA, Google, Twitter, and Facebook. So let's say you wanna use these providers, social media providers, to authenticate your user. Let's say your user has launched their app, let's say in an Android device, in an Android mobile device. You have developed an Android app, so and they want to authenticate by giving their Facebook user ID and password. You can do that in mobile app. Push notification support and custom backend logic in C sharp or node.js. All right, now let's look at Azure functions overview. Okay, so we've looked at VMs, containers. Within containers we looked at container instance, container apps, and Kubernetes, and then we've gone ahead and looked at Azure app service. Now let's try to understand what is Azure function. So Azure function is a event driven and serverless computing platform. Okay, so let's think of a scenario. Let's assume that when you upload an image to a storage account, you want that image to be processed to figure out whether that image is a cat image or a dog image. Okay, so in that situation wherein an event has happened and you want a computing to happen, in that case you can use Azure functions, right? And it's a serverless computing platform. So by serverless, what I mean is you don't need to create any VM or container for that. Okay, Azure would do it behind the scenes, so that's why it's called serverless. Functions run on event triggers, avoiding continuous resource provisioning. So as soon as an event has happened, like the one that I just mentioned, it runs. Okay, it runs on event triggers, so you don't need, therefore it avoids any continuous resource provisioning, right? So what are the benefits of Azure functions? Focus on code, as you know, as it's there for Azure app service as well. Ideal for prioritizing code over infrastructure management. Okay, you want to focus on your code optimizing it rather than focusing and wasting your time and energy on managing infrastructure. Triggered events, respond to events, timers, or messages from Azure service. Okay, so another benefit is you want to respond to any sort of events that happen, or any message that you receive from another app Azure service. That's when you want to use Azure functions. Auto scaling scales automatically based on demand for variable workloads, and cost efficient as well. charges only for CPU time during execution. Okay, so it only charges you for CPU time when it executes it, so it's cost efficient as well. Right. Now let's look at the resource management aspect of Azure function. Efficient allocation allocates resources on trigger, deallocates on completion. All right, this is a very important one. So whenever an event has happened, so Azure allocates resource like compute storage or CPU and RAM, and deallocates on completion. As soon as the task is done, it would shut it down, or it would just you know push it into the sleep mode. So deallocates on completion. Stateless, stateful. Stateless, so it's stateless by default, stateful, durable functions for flexibility. So it's a stateless function. So Azure functions by default is stateless. If you want to build a stateful, then you want to use durable functions. Okay, so what are durable functions? Stateful operations. So tracks prior activity by passing context through functions. So I'll tell you the major difference between stateless and stateful. So stateless function is a function that doesn't store the state of a previous activity. Okay, so it treats every request as a fresh one, a new one, and won't store the data from the previous activity, whereas stateful does store the data. That's what it says: tracks prior activity by passing context through function. Right. Let's look at the flexibility aspect of Azure function. So it's a general compute platform, versatile for running any code. Okay, you can run any code, uh, and easily deploy in non-serverless environment. Okay, you can deploy it in non-serverless environment as well, such as AKS. Okay, scaling options: manage scaling, run on virtual machines, or isolate function. So it manages the scaling, and it runs on virtual networks or isolate functions. Right. Let's look at last but not the least the cost model. So it's pay as you go, charges based on actual CPU time, ensuring cost efficiency. So the time it only for the time that it runs, it charges you that. That's how it's maintains cost efficiency. Right. So in conclusion, key for serverless computing. Okay, if you want to have serverless computing, then Azure function is your go-to resource, and powerful, adaptable, and cost-effective for event triggered code execution. Okay, perfect. So that's about it. Thank you so much. I hope this video was informative and it has given you a good bird's eye overview on the different Azure compute technologies that are there and when to use which. All right. Thank you so much. See you on the next video.